okay? So here we have an example, and we're solving this trig equation in two ways. Part A, we're solving on the interval 0 to 2 pi. So we're going to have a finite or limited number of solutions. And for part B, we're going to find all solutions or general radian solutions. So to get this started, the first thing that makes this one a little different than other equations we've seen in the past is instead of it just being theta or an x or whatever variable we might use, it has a 2 in front. So that does seem like it kind of raises a flag, like, wait a minute, this looks different. So what can we do? Well, let's pretend that it was just 2 sine theta equals negative root 3 for now. And we're going to go ahead and solve, put a big blue theta in this to get started. We'll do part A and part B. We're going to leave room, and then we're going to go and just tweak it a little bit because of the 2 theta. So what would I do to start this example if it were just an ordinary theta out in front over there? What would we do? Go ahead, Sammy.
Would you divide by 2?
Yeah, I would definitely divide by 2. Good. So if we divide by 2, we're peeling away those layers. We want to get sine theta alone so we could figure out theta. Sine blue theta, I'll put the blue in a second, is negative root 3 over 2. So right now, this isn't so bad, right? Like, this looks pretty standard, like something we've been working on. So if I were to solve this, part A, between 0 and 2 pi, I want to know what angles of theta on the unit circle between 0 and 2 pi, when I find their sine or their y value on the unit circle, they give me negative root 3 over 2. Which 2 angles? We should get two different angles. So I'm going to go like this and like this. Which 2 angles? Go ahead, Lispel.
4 pi over 3.
4 pi over 3. Yep, that's one answer. That's down in quadrant 3. What's another angle, Sharon?
5 pi over 3.
5 pi over 3. Yep, that's down in quadrant 4. Perfect. So if that were the question, we're just going to wrap this up. Got 5 minutes. So these 2 would be the answer if it was just theta. Go over here. I'm just going to set up part B as well. Part B, we would take those same answers. And what do we do at the end of each of those answers to make it all radian solutions, to make it a general solution? You take those same first answers, 4 pi over 3 and 5 pi over 3, and we kind of tack something to the end of it. What do we tack to the end of it? We just add something onto the end of these. So we went over that in examples 13, 14, 15, 16. 13 was a do now in class. 14, 15, 16, I asked you guys to copy into your notes for homework. And then we started an example also at the end of our last class. So Emerson, what would I add to the end of these over here?
2 pi n.
Well, plus 2 pi n, yes. Plus 2 pi n, plus 2 pi n. And 2 pi represents one full loop around the circle. And n is saying, up here, I'm going to put the little note, n is an element in the set of integers. So it means that n represents a number like 0, 1, 2, 3, or -1, -2, -3, a number like that. So now these are what we call general solutions, or it found us all our solutions. Now, just to finish this problem up, because it wasn't a big blue theta, right? We were solving, instead of for theta, theta was really a 2 theta. So what I'm going to do in the next step is I'm going to go ahead and revert it back to what the original problem was, okay? So in this step, I'm going to go ahead, I'm going to write 2 theta equals 4 pi over 3. And 2 theta equals 5 pi over 3. So looking at that and keeping in mind that our goal is still to solve for theta. If our goal is still to solve for theta and we want to get theta alone, okay, just stare pretty hard at it. Think about basic algebra. If my goal is to solve for theta, what can I do to get theta alone in both of these little itty bitty baby equations? I just need one more step to get theta alone. So who's gonna give me a little try over here? Mayan, go ahead.
Divide by 2.
Yeah, divide by 2. But whenever I have a fraction involved, instead of dividing by 2, I always choose to multiply. I think it looks a little cleaner. So what is dividing by 2 the same as multiplying by? Dividing by 2 is the same as multiplying by... Anyone? Shout it out.
2.
Well, dividing by 2 is not the same as multiplying by 2. Remember, keep, change, flip?
Multiplying by a half over.
Yes, 1 over 2 or a half. Good. So I'm going to multiply by a half everywhere. You get a half, 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 half. So it's the same as dividing by 2. This way you don't have to have a fraction being divided, you know? So then I get theta alone, theta alone. And what do I get? I get theta equals, I'm going to leave it over 6. So I'm going to get 4 pi over 6. And here I'm going to get theta equals 5 pi over 6. So now I just found 2 new answers. Does this one reduce? Yes. For now, though, I'm leaving it. You'll see why in the future. The common denominators are really helpful. Then all I'm going to do is here the same thing. Okay, we're just wrapping this up. We have 1 minute left. So get this example down. This is a major part of the lesson of the day, actually. This is like a critical example. I was going to use this to segue because I was hoping you guys would ask me about it, to segue into the next thing anyway. So this is the perfect example. I'm glad that you asked me about it. So if you write n easy like this on top of your page once, you don't have to write it a dozen times. You know, you could just keep it on top of the page, and every time you have n, it applies. I go ahead, I'm going to multiply everything again in both of these by a half. By a half. I get theta equals 4 pi over 6 plus, and then I get theta equals 5 pi over 6 plus, if I multiply 2 pi n by 1/2, can someone shout out, what does that turn into? What's 2 pi n times a half? What's half of 2 pi? Shout it out.
1.
Sorry, say it again.
1.
1 pi. And 1 pi, if I add it, I need a common denominator. We spent some time talking about common denominators, so I'm going to make it 6 pi over 6. 6 pi over 6 n. Now, while these are general solutions, I need them to get all of my solutions because these aren't all of them. Now, if I add 4 pi over 6 plus 6 pi over 6, can anyone tell me what that adds up to give me? What does that add up to give me? What is, so I'm going to get all my answers right here. So theta, this is really for part A, using part B over here. 4 pi over 6 was an answer, comma, 5 pi over 6 was an answer. But if I add 6 pi over 6 to 4 pi over 6, what do I get? Jeremiah, you're unmuted, just so you know. What would I get if I added 6 pi over 6 to 4 pi over 6? This is freebie participation, beautiful people. 4 plus 6, so we get
10 pi over 6.
Thank you. And that is less than 2 pi because 2 pi would be 12 pi over 6. What about if I added those? 5 pi over 6 plus 6 pi over 6. What would I get? And would it be less than 2 pi?
11 pi over 6, which is less than 2 pi.
Good. And then if I tried again, another 6, keep going because n could be anything, right? If I tried another 6 pi over 6, well, 10 plus 6, that's 16 pi over 6. That's too big. So obviously that one's too big. So now my real answer to part A is all 4 angles right here. So that's going to get us ready for our next lesson. Okay. So make sure you copy this one down. I'll post this up on the playlist also, but we actually have 4 answers to this problem. Again, the problem was this one over here. It was 24 on our worksheet. It was asking us to solve 2 sine 2 theta. So we would use this strategy anytime theta has a number kind of with it in that parenthesis. So we're going to keep that in mind. We're going to do a lot of practice with that next class. I'll probably have you copy a couple examples, maybe copy one and then try one just like it. Copy one, try one just like it. And we'll do that next time. but check over the homework, whatever I can get posted. I'll reopen the Do Now after school. Anyone that wants to redo it. If this is helpful as a video, let me know, thumbs up. If you're still confused, which I bet most people will be because it's new and awkward, this extra part, put a thumbs down so I could just track it. Okay. So I might just give you like 1 or 2 of these for homework and that's it. I'll decide by the end of the school day. Okay. Have a nice day.
Yeah, Miss Thomas. So the answers are 4 pi over 6 and 5 pi over 6.
Well, for the full thing, it's actually all 4 of
Oh,
those.
okay, okay.
Okay.
Got it. Yeah, thank
So
you.
yeah, we'll do more
No
practice,
comment.
but I'm glad that you asked about it. Is it a question about this example? Because I just about to hit stop recording, but if it's about this, I'll keep going.
Ms. Thomas?
Well, hold on. Sammy was in the middle.
Oh no, it's about something else.
All right, so I'll stop recording.